Hello, everybody. Happy Friday. I hope you all did well on the test. These grades, I'll be working on those, getting those in as soon as possible. Alright, so we're starting the new material for test 2, and it's going to be revolving around solving linear equations. Okay, so we already got kind of a head start on that at the very tail end of chapter 1, where we looked at one-step solves. So now I'm just going to open the floodgates of solving, because we understand the idea. It's the same goal and way of achieving it. We want to isolate the variable and use inverse operations. That's what solving is. But I want to kind of teach solving in steps. Okay? And this is kind of backwards of how we teach it, because what we did was the bottom step, where we just solve for x. And then the next step of difficulty is where we could put x on different sides, so we'll have to get them on the same side. And then the next step of difficulty is you'll have to require some simplifying. And then finally we'll start throwing fractions in, and you'll see that we can just get rid of the fractions. Now I do want to talk about some of these details before we hit them full force. For instance, I'm going to talk about what I mean when I say simplify. When I say simplify, it's going to involve 2 steps. It'll always be 2 steps. Every time I say simplify, I will say this for 100 million times, and you'll be really tired of me when I say simplify. What is simplify again? Simplify just means where we can, we will distribute. So y'all know how to distribute. For instance, if I have parentheses and stuff being added inside the parentheses, and then on the outside something being multiplied, I am allowed to distribute that and multiply by every term on the inside of the parentheses. See, 3 times 2 is what? 6. So that is a step in simplifying. The other step in simplifying is to combine like terms. So let me talk about that really quickly. When I say like terms, for instance, we'll be doing things like 2x plus 3 plus 5x. The things, well, let's add more, plus 7. The things that are like terms are the things that are alike with the variables that they have. Notice these 2 terms have an x, 2x, and 5x. So that means I can combine them, which just means I can add them. This is a positive 2x and a positive 5x. 2x's plus 5x's makes 7x's. Normal plain numbers with no x's are also considered common, so I can combine these like terms. Positive 3 plus positive 7 is a positive 10. So those are the 2 steps that we'll look at for simplifying. Once we hit that, that'll be like 3 or 4 examples in where we'll need to simplify before we can get the x's on the same side, before we can solve for x. Okay? So let's jump into the bottom. So we're going to hit an example that's just like this, where I just need to simplify. Then we'll hit an example where I need to get the x on the same side and then simplify. Then we'll hit our solve. Then we'll hit one where I need to simplify, get the x on the same side, then solve. And then we'll go that way. So we're building upside down. We'll start with the easier thing and add harder things as we go along. So they'll take more and more steps. Okay? So let's start with a very simple example of solving. And so for instance, 4x minus 15 equals 13. So if you think about those things that I listed over to the side, you could ask yourself those questions. Are there any fractions to kill off? The answer is no, so that step's done. Nothing to do there. Is there anything to simplify? No, that step's done. There's nothing to do there because there's no parentheses to distribute, and there's no like terms on the left side, and there's no like terms on the right side. Third step said third step was, is the x on the same side? Same side. Yeah, x is only on the left side of the equal sign. I don't have x's over here on the right, so that's good. You'll see all these things. So finally we get to solving. And so each time you do a problem, you should kind of run through this checklist in your head, or it'll kind of become second nature to you and you won't need to at some point. But we get down to solving. So is the x by itself? X by itself. And the answer is no, the x is not by itself. So can I get x by itself? So remember my questions I told you, looking at the same side of the equal sign, what things are with x? I see a 4 and I see a minus 15. Now the bigger question is, which one do I get rid of first, the 4 or the minus 15? I'll go ahead and tell you, after you kill off fractions, simplify, and get the x on the same side, all your problems will be very similar to this. They'll all be two-step solve, or if you're lucky, one-step solves. But when you're looking at this, we always start further away. It's kind of reverse order of operations. See, we would have, if this was just a 2, we would have multiplied and subtracted, right? But because we're undoing operations, we save the multiplication for last, we get rid of this subtraction. So this is where we start. So we got to get rid of the 4 and the 15. We're going to start further away from the x at the minus 15. So remember, our operations that we use are inverse operations. So what's the inverse, or what is the opposite of subtracting 15? Adding 15. Now remember, the whole idea of solving is I can do anything to the left side as long as I do that same thing to the right. So let's see what we have. I didn't touch the 4x, so it comes down. Negative 15 or minus 15 plus 15 adds to 0 or cancels. 13 plus 15, that will be 28. So then you can ask yourself the same question again. Is the x all by itself? And the answer is no, there's a 4 sitting there. What operation is understood to be right here? Multiplication. So what's the opposite of multiplying by 4? Dividing by 4. Now I can do anything I want to over here as long as I do it to the other side. So I'm going to divide both sides by 4. Now 4 divided by 4, that divides out to 1, or you can just say it's gone. So I'm left with x. And 28 divided by 4 is 7. So is x all by itself? Yes, it is. X is 7. So could I check it? The answer is yes, I can check it. For time's sake in this lesson, I'm not going to check every single one that we do, but you could if you wanted to. You could take the time and check every single one of these. So it was 4x minus 15 equals 13. 4 blank minus 15 equals 13. What did we find x was? 7. Let's see, 4 times 7 is 28. And 28 minus 15 is 13. So 13 does equal 13. So we know we're correct, and we finally finished solving. Alright? Awesome. That wasn't too hard. So now let's up the difficulty one step, where I have to consider if my x's are not on the same side. So I'll show you how to fix that. So let's look at an example like this. 2x plus 10 equals 5x minus 2. And so if you're running through this step of things, do I have any fractions to kill off? No. Do I have anything to distribute or like terms on the left? No. Do I have anything to distribute or like terms on the right? No. So then finally you get to, are the x's, all the x's on the left or the right? And you say, no, they're on different sides. I have x's on the left and on the right. So we need to fix this. But this is actually pretty easy to fix. You just cancel one out or do an opposite to one. And whatever I do to one side, I need to do to both. I always subtract off the smaller of the two, or add depending on if it's negative or positive. So this is positive 2x, so I'm going to subtract 2x from both sides of the equation. Now, since this term has an x in it, I can only add or subtract it with the term that has an x. I can't combine it with this 2. I got to combine it with the term that has an x. So let's see, when I do this operation, 2x minus 2x is gone, and I'm left with a positive 10. Be careful not to lose the sign. If this were minus 10, I would need to carry that minus down. Since it's positive 10, I don't have to write the positive sign. Bring down the equal sign. 5x minus 2x is 3x. So if you had 5 x's and you took away 2 x's, you'd have 3 x's. And we didn't mess with this minus 2 yet. So there. We have, now if you look, x is only on one side of the equal sign, not on 2. So now the last step is to solve, and if you click back, we already know how to solve something that takes 2 steps like this. Start further away from x, minus 2. So if you ask, is x by itself over here on the right side of the equal sign? No, there's a 3 and a 2. Which one do I get rid of first? The minus 2. What's the opposite of subtracting 2? Adding 2. So I'm going to add 2 to both sides. 10 plus 2 is 12. Bring down your equal sign. I didn't affect the 3x. Minus 2 and plus 2 is gone. Now, is x all by itself? No, it's not. The 3 is with it. That's understood to be multiplication. What's the opposite of multiplying by 3? Dividing this side by 3. Whatever I do on this side, I need to do on the other side. So the 3's are gone. X equals 12 divided by 3 is 4. In any step of arithmetic, you can use a calculator to go 12 divided by 3 if you were stressed about that. Okay? Awesome. So we've solved it. You could check it. Go ahead and believe me. We're correct. Alright. Awesome. Awesome. Let me start the check because this one has more x's in it. Notice there are 2 spots where you would need to leave blanks. I guess I'll check this one. So if we're going to check, probably be the last one I'd check just for time's sake, so you don't have to watch a 2-hour video or anything like that. So we found x to be 4. Notice I got 2 blank plus 10 equals 5 blank minus 2. 2 blank plus 10 equals 5 blank minus 2. Plug in those blanks. See, 2 times 4 is 8. 5 times 4 is 20. 8 plus 10 is 18. 20 minus 2 is 18. So yeah, we are correct. Alright, so let's keep building. Alright, if you look back at the beginning, I had 4 things we solved. We worked with x's on the same side. So now let's try one where I need to simplify, get the x on the same side, then solve. And then we'll finally build to our fullest height of challenging problems. So let's see here. Let's do maybe a few examples of these. So 2 parentheses. Doesn't matter what letter I use. Y minus 5 plus 3y equals 4, 3 plus 2y. Now a lot of people panic because this looks bigger and badder and scarier, but it's not. If you ask yourself those same questions, first question, do we have any fractions to deal with? I always try to get rid of fractions first. I don't see any fractions, so that's taken care of. Second step is, can we simplify? Remember, that means, do I have anything to distribute in any like terms? And you should immediately see on the left and on the right, I have parentheses. I have things to distribute. So yeah, let's simplify first. Simplifying is not to be confused with solving. We're actually not solving yet. We're just simplifying. And that means I'm just working on one side of the equal sign at a time. So 2 can be distributed to these. See, 2 times y is 2y. And 2 times a negative 5 is a negative 10 or a minus 10. Let's bring down this 3y. Okay, and I can distribute and simplify on this other side too. 4 times 3 is 12. And 4 times 2y is positive or plus 8y. Alright, we're doing good so far? Alright, are we done simplifying? Remember, simplifying is 2 steps. The 2 steps are you got to distribute and then you got to combine like terms. So there's nothing more to distribute, but I do have, if you look, these 2 terms are like on the same side of the equals. I notice they have to be on the same side for simplifying. 2y and a positive 3y, that is a positive 5y. I did not mess with the minus 10. Bring down my equal sign. 12 plus 8y. Alright, questions. Are we simplified? Answer is yes, we are. So next, the question is, do we have the x on the same side? Or the y, I guess I should say. Are we on the same side? No, I have an x on the left and an x on the right. But time out. We just did an example just like that with the x on the left and right. We have a y on the left and right. So this is exactly the same thing we already know how to do. The only new thing was simplifying to get to our green step. So now, I usually like to get rid of the smaller number. So this, if you look out front, is a positive 5y. So I need to subtract 5y from both sides. This is the first time I'm doing the same thing to both sides. Don't get that confused when you're simplifying. I'm only working on the left by itself and only working on the right by itself. But once we make it past simplifying, then I'm going to do this moving y's over. So let's see, what are we left with here? This is where I say don't forget to keep the sign attached to the number. This is a negative 10 or a minus 10. A lot of people drop that sign and get this problem wrong. 8y minus 5y is 3y's. Alright, so now hopefully I can solve this. So now we're to the final step of solving. Is y by itself? No, I have a 12 and a 3 to get rid of. Start further away. That's a positive 12, so I'm going to subtract 12 from both sides. Once again, being very careful here. Negative 10 minus 12, you could use a calculator if you wanted to check on that. It's negative 22 equals 3y. Y is not by itself yet. It has this 3 with it. So I'm going to divide both sides by 3. Now, if our answer simplifies, we should simplify it. If it doesn't, it is a-okay to leave it exactly like this. Negative 22 over 3. I'll go ahead and tell you this one does not simplify, but negative 22 over 3 is the correct answer. You could check it if you check it carefully with a calculator. You'll get nasty decimals, but that'll be okay. So, awesome. So we solved one that was pretty involved. We had to simplify and then move the x's or y's over to the same side, and then we had to solve. Let's do another one that's big like this, another example, just because these are bigger and it's practicing all the stuff we've already done. So another example like this that's a little bit bigger and badder. How about 3 parentheses y plus 5 minus 2 equals 6 minus parentheses y minus 5. This one is meant to be tricky and trick people. This is one they love to put on the test. I don't know if they're putting it on this year or not. We'll see. But you go to say, do we have any fractions? Nah. Do I need to simplify? You say, oh yeah, I see some things to distribute. And so you start out good. You go, okay, 3 distribute to the y is 3y. 3 distributed to the 5. 3 times 5 is positive 15. And bring down your minus 2. I'll keep going with simplifying. Do I have like terms? Yeah, I do have like terms. 15 minus 2, those can be combined. So I get 3y plus, let's see, 15 minus 2 is 13, equal sign. Okay, so the left side is simplified. Can I simplify the right side? And this is where they're really tricky. You go to distribute here, and there's not a number sitting right front. There's an operation. So if there's ever not a number in front of your parentheses, you can always put a 1 there so that it helps you see what's going on. Now, be very careful when there's a minus sign, because I am supposed to subtract off this entire thing. If I go to distribute to it, I'm going to need to say, hey, subtracting a number is the same thing as adding the opposite, adding a negative 1. So when I distribute this, I'll bring down my 6, bring down this plus sign, and distribute this negative 1. So negative 1 times y is negative y. Negative 1 times a negative 5 is positive 5. So just being very careful distributing this minus sign to all these terms in here. So now let's take a look. I do have like terms. I have 6 and 5. So I'm going to go minus y plus, what's 6 plus 5? That is positive 11. Okay. So, that simplifying was tough because it's very tricky. Anytime you have a minus sign and parentheses, distribute it like a negative 1. Okay, that's just some advice. That's a tip. They love to pull that trick a lot on the test because they know people will miss it. I think the people that write the test sometimes are a little bit mean. Okay, you'll get an example exactly like this in your worksheet whenever we do the worksheet. Okay. Alright, let's see here. So let's finish this one up. I have y's on different sides, so I need to get them on the same side. 3y and negative 1y, I'm going to get rid of the negative y. I'm going to add y to both sides. 3y plus y is 4y, and I can bring down everything else. Now I can solve. Finally I can solve. That's what I've been working towards. Is y by itself? No, I have 4 and I have 13. Which one do I need to get rid of first? Plus 13. So let's subtract 13 from both sides. 4y will equal, that's going to be what? Negative 2. Okay. And then finally, we're at the end here. We will divide by 4 to get y all by itself. I'm I guess I could scroll down. When I divide by 4, I get y equals negative 2 divided by 4. That will reduce to negative 1/2. And that is your final answer. Okay. Awesome. All right, a few more examples. Let's jump into fraction ones now. And I'll show you some more involved ones. I'll show you some easier ones. I'll show you the full variety of ones that you can see on the test. So for instance, let's start with one like this. X over 2 plus x over 3 equals 5. Okay. And if you're looking at this, and if you read through those steps that I wrote on the first slide, the first thing we come through is I have some fractions. So finally I can kill off some fractions. There are going to be several ways to kill off these fractions, but remember, all a fraction is a division. So this is like divided by 2, x divided by 2, x divided by 3. We already know how to do the opposite of stuff and cancel it out. So looking at this one, I can get rid of the division by multiplying. Now whenever I multiply, I have to multiply all the way through every term on both sides of the equal sign. And you could do this in pieces. You could multiply everything by 2, and then go by and multiply everything by 3, and then you will have canceled out the divided by 2 and the divided by 3. But the easiest way to do this is think, is there a number that would cancel out both 2 and 3 at the same time? And that number would be 6. If I were to multiply everything by 6. Now you go ahead and tell me why 6. Well, because 2 divides evenly into 6 and 3 divides evenly into 6. So what that means is I'm going to take a step to rewrite this. You don't have to show this next step. 6x over 2 plus 6x over 3 equals, let's see, what's 5 times 6 is 30. What that means is I can reduce this fraction right here, 6 over 2. Actually, if you were to do what's 6 divided by 2, it is 3. It doesn't mess with the x. The x is still there. So 6 divided by 2 is in front of the x. That's 3x. Bring down your sign. 6 divided by 3, that is 2. Didn't mess with the x. Oh, well, that's very nice and clever. Now I have no fractions left. Anytime you have an equal sign and you have stuff on both sides of the equal sign, I can kill off fractions just by using multiplications. I usually won't show the blue step. I will go straight from the black and green to the red, and all the fractions are gone. So now we can go through the rest of our steps. Do I have anything to simplify? I don't have anything to distribute, but I do have like terms here. These 2x and 3x are like terms, so I can combine them. Let's see. 3x plus 2x is, in fact, 5x. And then I don't have x's on both sides. I just have them on one, so I can go right to solving. And I could get rid of that times 5 by dividing by 5. So x equals 6. So that wasn't too bad. If you have a fraction, you can kill them off by just multiplying by a number that both of them will divide evenly into. So let's look at this maybe in a bigger problem. Let's see if I can keep it on the same page here so you can look at that for reference. And let's go to a bigger problem, one like this. X plus 3 over 5 minus 3x minus 5 over 10 equals 2 over 3. So a few things to point out. First, I would like you to draw in your implied parentheses. these will not be drawn in for you, but if you do not draw them in, I can guarantee there's probably going to come a step somewhere in here where you will miss what's going on. So I always start, when I have these big fractions that I'm solving, I go ahead and put what I wrote in green. Around these tops of the fractions that have a lot going on, I go ahead and put parentheses. Now let's get rid of the fractions. Let's multiply to kill off all these fractions. 5, 10, and 3. Is there a number that all three of them will divide into evenly? And I'm going to say yes, there is a number, and that number happens to be 30. So I got to multiply everything by 30. I am going to write this step this time just to be careful, since these are the first big fractions we're doing. So I'm just going to multiply everything by 30. Notice that means I'm just going to write 30 by the top of all the fractions. Okay. So notice I didn't strongly change anything here. It's still x plus 3 over 5 minus 3x minus 5 over 10 equals 2/3, and I put a 30 with each one. Now look what happens. Okay, let's see. 30 divided by 5, that reduces. 30 divided by 5 actually is just 6. 30 divided by 10 is just 3. And 30 divided by 3 is just 10. So let me rewrite what we have. I have a 6, and then I have parentheses x plus 3. I have a minus sign. I have a 3. And then I have parentheses 3x minus 5. Bring down your equal sign. I have a 10 times a 2. So now I have no more fractions. Now you can honestly just forget about everything we did up here and treat this exactly like some of the problems that we've done earlier. So we've killed off fractions. That means it's now time to simplify. I have things to distribute. That is 6x plus 18. Now be very careful right here. You see this minus sign? It belongs to the 3. Anytime there's an operation, it belongs directly to the number right behind it. Or anytime there's a number, look directly in front of it, and whatever's there belongs to it. So I got to distribute this as a negative 3. So negative 3 times positive 3x is negative 9x. Negative 3 times negative 5 is positive 15. Equals 10 times 2 is 20. A lot of people miss this problem because of this sign right here, because they don't put parentheses and they forget to distribute. Or if they do remember to distribute, they leave this negative sign and they don't pay attention to the fact that a negative times a negative gives you a positive. Now I can combine like terms. Let's see, 6x minus 9x is negative 3x, and plus 18 plus 15, that is, what is that, 33? Yeah, 33 equals 20. So now I have simplified. I've killed off fractions. I've simplified. My x's are only on the left. I can now finally solve. So you notice that each step by itself is not hard, but when you stack a lot up, people can get confused or intimidated. And I really, really, really strongly don't want you to be intimidated. But look what we made it. This is a problem that we already know how to solve. All I have to do is subtract 33 from both sides. Negative 3x will equal negative 13. And then I need to divide by negative 3. X will equal, let's see, a negative divided by negative is a positive. 13 over 3 does not reduce. So our answer is positive 13 over 3. Okay. That's about as nasty and mean of a problem as we can give you on this test. Alright. Now I'm going to show you two other little tricks that I like to throw on the test, which are not difficult, and they flow from this same idea right here. Okay, two more examples and I'll be done with you for the day. One like this. 0.03 parentheses x minus 6 equals x plus 2.73. Now, this is decimals. I really do not want to have to try to distribute this decimal. Could I? Yes, I could just simply use my calculator to figure out -6 times 0.03. But decimals are the same thing as fractions. So is there a way to cancel off 0.03 and 0.73? And the answer is actually yeah. The trick here is how many decimal places you got, 1, 2, 1, 2, or how many zeros you'll need to multiply by. Here's what I mean. Before I even bother distributing, I'm going to multiply this terms by 100, because 100 has 2 zeros. And I'll multiply all these terms by 100 as well, because that's how we do things, right? Now, if you grab your calculator and do this multiplication, 100 times 0.03 will just give you 3. Okay, now I don't need to distribute the 100 into the parentheses, because this 100 is multiplied by this whole thing. It just got multiplied out front. Once I distribute it, once I distribute the 3, that will distribute that through there. 100 times x is 100x plus, and 273 is actually 273. So I didn't even need a calculator to multiply by 100, because what multiplying by 100 does to decimals is move it 2 decimal places, because it's 1, 2 zeros. 1 and 2 zeros means move it 2 decimal places. So now I can just quickly solve. Distribute, that'll be 3x minus 18. 3x minus 18 equals 100x plus 273. So let's get the x's on the same side. So let's see, minus 3x from both sides. I'm left with minus 18 equals, that'll be what, 97x plus 273. Now, can I solve for x? Yeah, let's get rid of 273. So minus 273 from both sides. Whew, might need a calculator here. 97x negative 18 minus 273. Let's see, that should be negative 291, if I'm thinking clearly. Yeah, I believe that's right. And then finally, I can finish solving by dividing by 97. I don't care how nasty the numbers are, you can always type this in a calculator. You could also type this in a calculator, and if you do type it in a calculator, you'll find that's negative 3. So there. It's a pretty number. It just took a lot of work to get there. One more example. They like to put one with decimals on the test. They also like to put one like this on the test. So killing off decimals is the same thing as killing off fractions. So half parentheses 3x plus 1 equals 1/3 parentheses 5x minus 2. Once again, I'm going to want to start with killing off these fractions. We've already done a 2 and a 3. What number is it that both 2 and 3 divide evenly into? It's 6. So I'm going to multiply each side by 6. We get lucky here because this is actually really easy. 6 times 6 divided by 2 is 3. And 3 divided by 2 is, divided by 3 is 2. So what are you left with? 3, and then what's in the parentheses? Equal sign, 2, and then what's in the parentheses? All I did was simplify these fractions out front. Now I can distribute and solve. 9x plus 3 equals 10x minus 4. I have x's on opposite sides, so I'm going to subtract 9x from both sides. To get my x's on the same sides. So 3 equals, that is just 1x, or x, minus 4. Now all I have to do is add 4 over, and I have finished solving. So 7. So x equals 7. So that's actually pretty simple too. Alright? So make sure you practice this. Make sure you do the My Math App homework, but especially do the worksheet. The worksheet is chopped full of things that are very similar to this. and especially similar to this, which are very, very similar to things on the test. So they will strongly, strongly, strongly help you. And if you could do all this, then the rest of the chapter really shouldn't be that hard. Alright? Well, I'll let y'all go. I will see you on Monday.